Hi everyone. In the last class, we saw the problems on finding the inverse Laplace transform by using the elementary elementary formulas for the elementary functions, using the inverse Laplace transform of elementary functions. Next, followed by using the first shifting theorem, we have evaluated inverse Laplace transform. Now we write the second shifting theorem. The proof also will get from the already we discussed in the Laplace transformation case. Is the second shifting theorem. If L inverse of f of s is equal to f of t, this is same as L of f of t is equals to f of s, right? L inverse of f of s is equals to f of t. Then L inverse of e to the power of minus as into f of s. E to the power of minus as into f of s is equals to f of t minus a for what values of t? It is t is greater than a, and 0 for t is less than a. Here, which is same as f of t minus a. If you are writing in terms of a besides a unit step function, this may be written as f of t minus a into h of t minus a, where h of t minus a is a besides unit step function. It is defined by h of t minus a is equals to 1 for t greater than a and 0 for t less than a. Here in this case, if you write f of t minus a into 1 for t greater than a, that is f of t minus a. Yes, f of t minus a into 0 for t less than a, yes, you will get 0, right? This is the second shifting theorem in the inverse Laplace transform. The proof also same. After getting the proof, when you are applying the Laplace transform for the function f of t, just you take out that L to the LHS, or L of f of t is equal to f of s. You take that L the Laplace transformation operator, take out to the RHS, it becomes inverse Laplacian operator. You will get this, right? This is a second shifting theorem. Now we are trying to solve problems on this by applying the second shifting theorem here. Evaluate L inverse of e to the power of minus 4s divided by s minus 3 whole to the power of 4. Listen, if you see this input, first you go for 1 by s to the power of 4, 1 by s minus 3 whole to the power of 4, next e to the power of minus 4s divided by s minus 3 whole to the power of 4. That means we recall the L inverse of 1 by s to the power of n, s to the power of n plus 1 formula, L inverse of 1 by s minus a whole to the power of n plus 1 by applying the first shifting theorem, L inverse of e to the power of minus as divided by some s minus b whole to the power of n plus 1. For this one, the inverse Laplace transform of the elementary function. For this one, first shifting theorem. Here it is second shifting theorem. Right. Listen. Now I am going to take, let f of s is equals to 1 by s minus 3 whole to the power of 4. Yes, L inverse of f of s is equals to L inverse of 1 by s minus 3 whole to the power of 4. Yes, in place of s, what is there? S minus 3 is there. That means when we are combining the given function with e to the power of at, s is replaced with s minus a. I am going to take out e to the power of 3t into L inverse of 1 by s to the power of 4. Is it clear? By applying the first shifting theorem here, directly I am writing. Or if you want to take, since you know that L inverse of 1 by s to the power of 4 is equals to s to the power of 3 plus 1, it is t to the power of 3 divided by 3 factorial here, right? So from that you will get, or directly you can write it, no problem at all, which is equals to e to the power of 3t. Here it is L inverse of 1 by s to the power of 3 plus 1. If n is a positive integer, then 1 by s to the power of n plus 1 can be written as t to the power of n divided by n factorial. So which is t cube divided by 3 factorial. which is equals to 1 by 6 into t cube e to the power of 3t. So what we have, L inverse of f of s is equals to, which is equals to f of t I am taking, that f of t is what, 1 by 6 into t cube e to the power of 3t. Now we go for the second shifting theorem. By applying the second shifting theorem, L inverse of e to the power of minus as into f of s is equals to L inverse of this, which is, you know that f of t minus a for t is greater than a, 0 for t is less than a. E to the power of minus as, it is nothing but minus 4s into f of s we taken already, it is 1 by s minus 3 all to the power of 4, which is equals to f of t minus a is equals to, what is there, 4 is there, t minus 4 for t is greater than 4, 0 for t is less than 4, which is same as, see next step, which is same as f of t minus 4 I am writing, or just f of t minus 4, or directly if we write in terms of besides a unit step function, f of t minus 4 into h of t minus 4. Right, here it is f of t minus 4. You have f of t, no, which is 1 by 6 of t minus 4 whole cube e to the power of 3 into t minus 4 is h of t minus 4, one way of representing. Or if you write in terms of the function, what I am writing, 1 by 6 t minus 4 whole cube e to the power of 3 into t minus 4 for t is greater than 4, 0 for t is less than 4. This is the evaluation process. Next, second problem. Evaluate L inverse of e to the power of 4 minus 3s, e to the power of 4 minus 3s divided by s plus 4 all to the power of 5 by 2. Yeah, this can be written as L inverse of e to the power of 4 into e to the power of minus 3s, we can write it e to the power of minus 3s into e to the power of 4 divided by s plus 4 all to the power of 5 by 2. This is considered to be what? F of s. Let f of s is equals to e to the power of 4 divided by s plus 4 all to the power of 5 by 2. Now L inverse of f of s is L inverse of e to the power of 4 divided by s plus 4 all to the power of 5 by 2. See here, instead of s plus 4 is there, you take out e to the power of minus 4t to the before the inverse Laplace transformation, e to the power of 4 e to the power of 4, it is a constant, e to the power of 4 into, by applying the first shifting theorem here, now I am applying the first shifting theorem, e to the power of minus 4t L inverse of 1 divided by s to the power of 5 by 2, right, which is e to the power of, the base are equal, then we add the powers, 4 minus 4t L inverse of, here it is 1 by 5 by 2 can be written as s to the power of 3 by 2 plus 1. N is being positive integer, we can write it in the previous t to the power of n divided by n factorial. It is not an integer, it is a real number which is greater than minus 1. So this can be written as e to the power of 4 into 1 minus t. Here it is t to the power of n. T to the power of n, it is nothing but t to the power of 3 by 2. T to the power of 3 by 2 divided by, here it is gamma of 3 by 2, or gamma of n plus 1 actually. Gamma of n plus 1 is what? 3 by 2 plus 1, it is 5 by 2. Gamma of 5 by 2. So this can be written as 4 into 1 minus t to the power of 3 by 2 into 1 by gamma of n is what? N minus 1, gamma of n minus 1. So 5 by 2 minus 1, it is 3 by 2. 3 by 2 into gamma of 3 by 2. Listen, gamma of 5 by 2 is what? 3 by 2 gamma 3 by 2 Gamma of 3 by 2 is what? 3 by 2 minus 1, 1 by 2, gamma 1 by 2. Here it is 3 by 2, 1 by 2, gamma 1 by 2 is what? Root pi. So 3 by 2, 1 by 2, root pi. So here it is 2 into 2. 4 is there, no? 4 coming to the numerator. So we have 4 by 3 root pi. E to the power of 4 into 1 minus t, t to the power of 3 by 2. This is your f of t. This is your f of t. Inverse Laplace transform of e to the power of minus 4s, no? Minus 3s into f of s is equals to f of t minus 3 for t is greater than 3, 0 for t is less than 3. Yeah, which is equals to your f of t we have, no? So 4 divided by 3 root pi e to the power of 4 into 1 minus t replaced with t minus 3, t minus t plus 3 into t minus 3 whole to the power of 3 by 2 for t is greater than 3, 0 for t is less than 3. Here it is 4, no? 3 plus 1, 4 minus t e to the power of 4 into 4 minus t into t minus 3 whole to the power of 3 by 2 for t is less than greater than 3, 0 for t is less than 3. This is same as f of t minus 3 into h of t minus 3, which is f of t minus 3. This is h of t minus 3 besides unit step function. Next, in the same way you are trying to solve these problems. What is the answer you are expecting here? 1 by s square plus 1 is 1 by a into sin at, that is sin at f of t, pi is there. So here it is sin of f of t minus a, it is pi minus t, t is greater than pi, 0 for t is less than pi. E to the power of minus 2 pi by, so you may write it sin of 180 minus theta, that is sin theta, that is clear, 2 pi by 3s by s square plus 9. What you are going to expect the answer? S divided by s square plus 3 square, cos 3t, actually cos 3t, no? So which is cos of t 3 into t minus 2 pi by 3 for t is greater than 2 pi by 3, 0 for t is less than 2 pi by 3. Same here also, you can expect the answer. If you write, if you are not writing in this form, you can write it besides unit step function. Here it is cos h omega t. So what I am writing, cos h at, actually omega t, omega into t minus a for t is greater than a, 0 for t is less than a. Is 3 into 1 plus e to the power of minus s pi by s square plus 9. Separate it. Here it is 3 divided by s square plus 9 it is, that is different. Or if you take this is you separate the terms, you will get the, this is two terms you will get here. L inverse of s plus 1 e to the power of minus pi s divided by s square plus s plus 1. As a denominator you may write it 1 by 2 into 2s, 2 into 1 by 2s plus adding 1 by 2 and subtracting 1 by 2, you will get the formula. Here in this case s square plus 2 into 1 by 2 into s plus 1 by 2 minus 1 by 2 plus 1. So this is 1 by 4, 1 by 4. This is nothing but s plus 1 by 2 whole square. Here it is minus 1 by 4 plus 1, it is minus 1 plus 4. 1 minus 1 by 4 plus 3 by 4 root plus root 3 by 2 whole square in the denominator for this. Next, three divided by s, 4 e to the power of minus s divided by s square plus 4 e to the power of minus 3s divided by s square. First we separate it by using the linear property, then apply the second shifting theorem for this, second shifting theorem for that. Okay, these are the problems on second shifting theorem. Next, change of scale property. Same that statement we are writing in inverse Laplace transformation. Change of scale property. Yes, what is that? If L inverse of f of s is equals to f of t, then L inverse of f of as is equals to 1 by a into f of t by a. Proof also same. You may try for the proof. F of at we written here there. The rest by a will get. Here it is. If you go for the proof, you will get the proof by applying the definition of the Laplace transformation and our inverse Laplace transformation. Now coming to one problem on this. Here, if L inverse of s divided by s square plus 1 whole square is equals to 1 by 2 t sin t, then find L inverse of 32s divided by 16s square plus 1 whole square. Right. Now coming to the solution, given that L inverse of s divided by s square plus 1 whole square is equals to 1 by 2 into t sin t. See, instead of s, what is there? 16s square is there. Yes, I am going to write s is equals to 4s directly. If I am writing s is equals to 4s in this case, put if you go for which is f of t, I think, which is f of t, this is f of s, put s is equals to as, so it becomes as f of as. F of as it is as divided by s square plus 1 or a square s square, a square s square plus 1 whole square is equals to 1 by 2 into t by s, by using that property, change of scale property, 1 by a into So 1 by a also will get 1 by 2 already there, 1 by a into f of t by a. Here f of t by a, it is 1 by a into f of t by a, which is 1 by a, 1 by 2. F of t by a is what? T by a into sine of t by a. Yeah. So when we get that answer, if I am taking a is equals to 4, we may expect some 4s will get there. The numerator 4s, the denominator it is 4 square 16s square. In this, if you take this as equation number 1, this is equation number 2. Let's put a is equals to 4 into, so L inverse of AS is nothing but 4s divided by a square 16s square plus 1 whole square is equals to, write 1 by 4, 1 by 2, t by 4, right, t by 4 sine of t by 4, right. What we required here, 8. You take out 4 into 2, 8 is there. 8 by cross multiplication, it becomes 8 into L inverse of 4s divided by 16s square plus 1 whole square is equals to, yes, this term it is we take out this term to the left hand side, t divided by 4 we have t divided by 4 sine t by 4, or you take out this 8 inside the bracket, so it is 32s divided by 16s square plus 1 whole square is equals to, this is the answer. Next problem. The same way, the same manner you are trying to complete these problems. E to the power of minus 1 by s divided by s to the power of 1 by 2 is equals to cos 2 root t by root pi t. Find L inverse of, yes, you will get the clarity what you are going to take, s to the power of 1 by 2. First you take s is equals to a there, you take a, it is first s is equals to some ks, first step, then k is equals to, what do you get, 1 divided by ks we have, right, 1 divided by ks we have by applying the change of scale property. Or if you see this, put s is equals to ks, L inverse of e to the power of minus 1 divided by ks, here it is ks whole to the power of 1 by 2 is equals to, this is f of t, no, 1 by a into 1 by k into f of t by k. So which is 1 by k, f of t by k is same as cos 2, it is t by k root pi t by k. Next, for as if we take k is equals to 1 by a, we will get the answer, k is equals to 1 by a. So L inverse of e to the power of 1 divided by 1 by a of s, here this is a fraction, a coming to the numerator. Sorry, it is only s, no, only s, not 1 by s. So what will be s by a, s is equals to 1 by a, k is equals to 1 by a, it becomes, what we expect, s divided by 1 by a coming to the numerator minus as divided by, here what, k is equals to 1 by a, 1 by a into s. So 1 by a into s to the power of 1 by 2, or a to the power of 1 by 2 also, this is coming to the numerator, is equals to 1 divided by 1 by a cos of 2 into t divided by 1 by a by root pi into 1 t divided by 1 by a. So which is this root a coming to the numerator. So what we have, root a by 2. Root a by 2 is a constant. That implies a to the power of 1 by 2 L inverse of e to the power of minus as divided by s to the power of 1 by 2 is equals to here a cos 2 root at by root pi at. So you take out this a to the denominator, a to the power of 1 by 2 will get there. Or if in the denominator, if you get that a to the power of here it is 8a and root a, 1 root a is there, root a get cancelled, we have cos 2 root at divided by root pi t is the answer. Next, if L inverse of s divided by s square minus 16, this is nothing but what? You know that s divided by s square minus a square cos h80 cos h40, actually this is cos h40, which is cos h40. Then prove that L inverse of s divided by 2s square minus 8 by using the change of scale property 1 by 2 into cos h2t. So you will get the clarity what you are going to take to get the term. First s is equals to some ks, then which one you are taking, k is equals to which constant is suitable for that to get the required answer. Just replace it like this. We have the problems on change of scale property. Next one, inverse transformation of derivatives. Inverse transformation of derivatives. As everything we have the proofs. If you want to prove, then you try it by using the definition. We'll get the proof of each theorem, right? If L inverse of f of s is equals to f of t, then L inverse of d to the power of n divided by ds to the power of n of f of s is equals to minus 1 whole to the power of n. Same, that is what multiplied by t to the power of n is same as multiplied by t to the power of n in the Laplace transformation is same as inverse transformation of derivatives in the inverse Laplace transformation, right? It is t to the power of n of f of t. This is the same. You prove that one multiplied by t to the power of n, you take out that L to the right side, we'll get the answer. Okay, now coming to one problem on this. Is it clear for the statement? L of f, this is same as L of f of t is equal to f of s, that is function of s. Then Laplace transform of t to the power of n into f of t is equals to minus 1 whole to the power of n into d to the power of n divided by ds to the power of n of f of s. Already we proved this one in the Laplace transformation. We solved the problems on the multiplied by t to the power of n in the Laplace transformation, right? Next, see one problem on this. L inverse of, evaluate L inverse of s divided by s square plus a square whole square. Yes, here it is, there is a flexibility in finding the inverse Laplace transformation. If you apply this one, no problem, by using this statement you will get the answer. Otherwise we have some properties, basic properties, or next we discuss the convolution theorem or the other properties. You may find the inverse transformation of the function of s. Right, here it is. Listen, this is the input here. if we have s divided by s square plus a square, then we can write it cos at. But s divided by s square plus a square whole square is there. Now I am going to take, now I know the some idea, right? By inspecting the given function, that means I will get some idea. What is that? I am going to take f of s is equals to 1 divided by s square plus a square. The derivative is different, right? So that implies d by ds of f of s is equals to, here it is, d by ds of 1 divided by s square plus a square, which is minus 1 divided by s square plus a square, right, into s square derivative is what? 2s, which is minus 2s divided by s square plus a square. So finally what we have? D by ds of f of s is equals to minus 2s divided by s square plus a square, or this is same as minus 1 by 2 into d by ds of f of s is equals to, sorry, whole square we have, minus 1 by x square, no? Here it is s divided by s square plus a square whole square, right? We have the term. Now I go for this one, right? Now I am going to apply the inverse transformation of derivatives here. Listen, now I am writing the statement L inverse of, I am trying to write this one, minus 1 by 2 into, right, minus 1 by 2 into d by ds of f of s is equals to L inverse of, yes, minus 1 by 2 into d by ds of f of s is equals to what we have, which is same as, or you take out minus 1 by 2 there. Let's see, which is minus 1 by 2 into L inverse of d by ds of f of s, yeah, which is same as minus 1 by 2 into L inverse of d by ds of n is equals to 1 is there, which is same as minus 1 whole to the power of 1 t to the power of 1 f of t. But if you know the f of t, you will get the answer, right? Which is same as minus into minus plus, which is 1 by 2 t f of t. How we can get the f of t? We take in the f of s, no? Since f of s is equals to what I taken, here it is 1 divided by s square plus a square. L inverse of f of s is equals to 1 divided by L inverse of 1 divided by s square plus a square, which is same as 1 by a sin a t. This is your f of t. So we have, finally what we have, 1 by 2 t into 1 by a sin a t. This is same as t divided by 2a sin a t, right? Is it clear? Okay, by using this one we can evaluate the s divided by s square plus a square whole square. Next, the same way, same problem I am giving, evaluate L inverse of s divided by s square minus a square whole square. What is the answer you are expecting here? T divided by 2a sin HAT. Next, next problem. In terms of logarithms, third one, L inverse of log of 1 plus s divided by s. Listen, now I am going to take f of s is equals to log of s. This method also very important, 1 plus s by s. Log a by b is log 1 plus log a minus log b, log s. Now I go for L inverse of f of s to get the f of t. L inverse of d by ds of f of s I am finding, or find out L inverse of f of t. F of s is equals to L inverse of log of 1 plus s. Yes, no problem. This is not possible. So derivative, we can find the derivative. So d by ds of, actually we are going to find L inverse of f of s, that is we need to find. So that is not possible here. We don't have any formula for logarithm, right? D by ds of f of s I am trying to find, which is equals to d by ds of f of s is what? D by ds of f of s is log 1 plus s minus log s. So which is 1 divided by 1 plus s minus 1 by s. L inverse of f of s is equals to L inverse of d by ds of f of s is equals to, what is the principal inverse transformation of derivatives? Minus 1 whole to the power of n, minus 1 whole to the power of n, t to the power of n, f of t, right? So which is L inverse of d by ds of f of s, what we have? 1 by s plus 1 minus 1 by s, right, is equals to minus t to the power of 1 is there, no? So better to take here, it is 1. Here it is minus t into f of t, right? L inverse of 1 by s plus 1, it is e to the power of minus t minus 1, which is equals to minus t into f of t can be written as L inverse of f of s, right? See here, what is the trick applying here? Our objective is what? If when I am taking f of s is equals log of 1 plus s divided by s, we are going to find L inverse of log of 1 plus s divided by s. That is not possible. There is no fundamental formula for finding log of 1 plus s divided by s for the inverse Laplace transformation. I am going to applying here. So here it is f of t. Since L of f of t is equals to L inverse of f bar of s is same as what? F of t. So f of t is replaced by what? L inverse of f bar of s. So yes, you take out this t to the right side, left side. L inverse of f of s is equals to, so it is if you common minus 1 minus e to the power of minus t divided by t. So what is your f of s? L inverse of log 1 plus s divided by s is equals to 1 minus e to the power of minus t divided by t. This is the procedure. Is it clear? Next. In the same way, we go for another problem here. Log of s plus a divided by the same way, s plus a divided by s plus b. Yes, the same way you are trying to complete. What you are taking here? F of s is equals to log of s plus a divided by s plus b. It is log of s plus a minus log of s plus b. So d by ds of f of s is equals to d by ds of log s plus a minus log s plus b. 1 divided by s plus a minus 1 divided by s plus b. So L inverse of d by ds of f of s, inverse transformation of the derivatives, minus 1 to the power of n, t to the power of n, f of t. So L inverse of 1 by s plus a minus 1 by s plus b minus t. F of t is what? L inverse of f of s. Right, here it is 1 by s plus a e to the power of minus at e to the power of minus bt by minus t is equals to L inverse of f of s. So finally what we have? If we common minus t, e to the power of minus bt minus e to the power of minus at by t is equals to L inverse of log s plus a by s plus b. This is the evaluation process. Next, fifth one, L inverse of log 1 plus omega square divided by s square. Sixth one, L inverse of log s square plus 1 divided by s minus 1. Just solve it. I'll continue in the next class.